another important thing, now we completed the Ampere circuit law and its application. So now we are going to see the Lorentz force. So Lorentz force is a very important one. So using that Lorentz force, we are going to see the applications. So Lorentz force. So you know that when the charged particles are placed in a uniform magnetic field, so nothing is experienced, but the charge is at rest. That is, rest means we studied the property of the charge at rest in electrostatics. But here, when the charge is moving inside the magnetic field or electric field, it experiences the force. That force is called magnetic Lorentz force. That force is called magnetic Lorentz force. So the magnetic Lorentz force, due to that, the particles are moving in a circular path. So பார்த்தீங்க அப்படின்னா சார்ஜ் ரெஸ்ட்ல இருக்குதுன்னா அதனுடைய ப்ராப்பர்ட்டி என்ன அப்படிங்கிறத ஃபர்ஸ்ட் லெசன்ல படிச்சிட்டோம். ஆனால் ஒரு சார்ஜ் மோஷன்ல இருந்துச்சு அப்படின்னா ஒரு ஃபீல்டுக்குள்ள எலக்ட்ரிக் ஃபீல்டுக்குள்ளேயோ மேக்னெட்டிக் ஃபீல்டுக்குள்ளேயோ அந்த சார்ஜ் இருந்தால் the charge is moving in the form of circular motion. Okay, it is definitely in the motion. So it experiences a force, another one force. That force is called magnetic Lorentz force. So the magnetic Lorentz force அப்படிங்கிறது என்ன அப்படிங்கிறத நம்ம விஷுவலாக பார்க்கலாம். So how the particles are moving inside the force. See that? So a particle is moving inside the magnetic induction. That is B, magnetic field charge. So it is moving like this. F is the force, V is the velocity. These two components are perpendicular to each other. So F vector equal to BQV. QV is charge, V is the velocity, and B is the magnetic induction. So when the charge is placed inside the magnetic induction, it will move like this. So it's called magnetic Lorentz force. That force F is equal to BQV. B vector cross QV vector, or you can write it BQV sin theta. ஏன்னா கிராஸ் ப்ராடக்ட் இருக்குது, கிராஸ் ப்ராடக்ட் இருந்தால் உங்களுக்கு என்ன பண்ணணும்னு தெரியும். That is BQV sin theta. So that particles are moving inside the field is like this. So all the particles are moving in a circular motion. See that? The particles are moving in a circular motion. It is not moving in a linear motion. So it experiences the force. The force is called magnetic Lorentz force. So just two components, one is the force, another one is the V velocity. See how the particles are moving in the magnetic field. So it's called magnetic Lorentz force. So the particles are moving in a circular path. Suppose another one field, that the magnetic field and electric field is fixed. So the particles are moving in that the total force F is equal to Q into E vector, V vector plus B vector. So ரெண்டு ஃபீல்டு இருந்ததுன்னா இது வந்து மேக்னெட்டிக் ஃபீல்டு மட்டும் இருந்தா எலக்ட்ரிக் ஃபீல்டும் சேர்ந்து இருந்தது அப்படின்னா இட் எக்ஸ்பீரியன்ஸஸ் த டூ ஃபோர்ஸஸ். We have to add the electric field and the magnetic field. So it is moving like this. Okay, this is the earth magnetic field. Due to that, the particles are moving like this. So it's called magnetic Lorentz force. Next, we are going to see the force on a moving charge in a magnetic field. இப்போ அதுக்கான கண்டிஷன் பார்ப்போம். ஒரு சார்ஜ் இருக்கு, அந்த சார்ஜ் வந்து ஒரு எலக்ட்ரிக் ஃபீல்டோ மேக்னெட்டிக் ஃபீல்டோ போச்சு அப்படின்னா எக்ஸ்பீரியன்ஸ் ஆஃப் ஃபோர்ஸ்னு சொல்லிட்டோம். ஸோ அதுக்கான கண்டிஷன் என்ன, வாட் ஆர் த கண்டிஷன் when the charge is moving in a magnetic field அப்படிங்கிறத தான் நெக்ஸ்ட் நம்ம பார்க்க போகிறோம். So Lorentz magnetic force means that force Fm is equal to Q into B vector cross B vector. So two fields are right angle to each other, you know that. And or you can write BQV sin theta. Suppose you put F vector, that is n cap, will give the direction of the force, right? So here the direction of the force will explain that on the basis of Fleming's left hand rule. So Fleming's left hand rule is that something indicates the force, forcing a magnetic field and electric current for the center. So suppose here two forces are acting, that is here B means magnetic induction, E means electric field. Suppose the two forces are acting on the particle, we have to add the two values. So we will get F vector equal to Q into E vector plus V cross B அப்படின்னு எழுதிக்கலாம். ஸோ இங்கே வந்து ஒரே ஒரு இது மட்டும் இருந்துச்சு அப்படின்னா இது மட்டும் வந்திருக்கும். இது வந்து மேக்னெட்டிக் ஃபீல்ட், இது எலக்ட்ரிக் ஃபீல்ட். ரெண்டுமே வந்து we have to add the two fields, electric field and the magnetic field. ஸோ இப்போ அந்த இதில் வந்து எப்படி இருக்கும் அப்படின்றத கண்டிஷன் பார்ப்போம். ஸோ மோஷன் ஆஃப் எ சார்ஜ் பார்ட்டிகல் இன் அ யூனிஃபார்ம் எலக்ட்ரிக் ஃபீல்டு. ஸோ I can take the 3 axis x, y, z axis. So B is the magnetic induction. Z axis la magnetic induction இருக்கிறதா வச்சுக்குவோம். சார்ஜ் Qங்கிற ஒரு சார்ஜ் இருக்கு. அந்த சார்ஜோட மாஸ் m, that is placed in the xy plane. So when you place the charge at the point B, it experiences the magnetic induction B because it is acting perpendicular to the charge, and V is the velocity of the particle. Okay. So according to the Matt-Lorentz force F vector equal to Q into V cross B. That another one force acting towards the center of the point O. That's why the particles are moving in a circular motion. Since the force acts in perpendicular to its velocity, the force does not do any work. So that force does not do any work. It only changes its direction. So the magnitude of the velocity remains constant, and only its direction changes. That's why the particles are moving in a circular motion. So it only changes the direction. So direction means the particles are moving in a circular motion. So I can consider the 3 point PQR. So different position, the magnetic field is perpendicular to the charge. It's moving in a circular path. All the forces are acting towards the center of the point O. So it is moving in a circular path. So F is equal to multiply cross multiplication, you will get BQV sin theta, sin 90 degree. That's why that is become 1. So F is equal to BQB. That is the force experienced by the particle. That force is called the magnetic Lorentz force. So that will provides the necessary centripetal force. So the particles are moving in a centripetal force means BQV equal to mv square by r. That is the centripetal force. Because BQV equal to mv square or r equal to mv by BQ. It is evident from that equation that the radius of the circle path is 0. Path is proportional to mass of the particle, velocity of the particle. So ரெண்டுக்கும் proportional இருக்குதுன்னு பார்த்தோம். So from equation v by r equal to, we can write bq by m, or omega equal to b by r ங்கிறது என்னது omega. So angular velocity equal to velocity by v by r. v equal to r omega, or omega equal to v by r. There is a relation between linear velocity and angular velocity. So period of rotation, time period, t equal to 1 by f, 2 pi by omega. Angular displacement by angular velocity, 2 pi by omega. Or you can write, substitute the value of omega, you will get t equal to 2 pi m by b cube, or omega equal to b cube by m. So t equal to 2 pi m by b cube. From the equations 2 and 3, it is evident that angular frequency and period of rotation of the particle in the magnetic field do not depend on the velocity of the particle and radius of the particle. See, velocity அல்ல v-யும் கிடையாது, r-ம் கிடையாது. So the period of time period is not depending on the velocity and the radius of the path, circular path. ரெண்டையும் டிபெண்ட் பண்ணி இருக்காது அப்படிங்கிறது நம்ம இதுக்கு தெரிஞ்சுக்கலாம். So it's a very important one. So the time period is not depending on the velocity of the particle and the radius of the circle. சரி, அப்படி இருக்க அப்போ எப்படி போயிட்டு இருக்கோம்? இந்த பார்ட்டிக்கல் வந்து வெலாசிட்டியை பொறுத்து இருக்காது. அதனால வந்து பெரிய சர்க்கிளாக இருந்தாலும் சரி, சின்ன சர்க்கிளாக இருந்தாலும் சரி, the time period is same. So the time period is not depending on the radius. அப்போ பெரிய சர்க்கிளாக இருந்தால் அதிகமாக நேரம் சுற்றும், சின்ன சர்க்கிளாக இருந்தால் கம்மியாக சுற்றும், அப்படி கிடையாது. So whatever may be the radius, the time period is same for all the particles which is rotating and revolving in the magnetic field. Okay, so it is not depending on the velocity and the radius of the circular path. So see that how it is moving inside the magnetic and the electric field. So helical motion in the magnetic field. So ரெண்டுமே இருந்து அப்படியே சர்க்குலரும் இருக்கு, velocity v straight line இருக்கு அப்படிங்கிறதுனால. So north and south it's a magnetic field. When charge q is moving inside the magnetic field, it experiences the force. It has the linear velocity v on one direction. So v is acting on the one direction that is parallel to them. It experiences the magnetic Lorentz force of q equal to v cross b. V is velocity, b is magnetic induction. V is parallel to the field. So see that PPE and VPA. So that velocity is divided into two components. One component is parallel and one component is perpendicular. So VPA is parallel to the magnetic direction, VPE is perpendicular to the magnetic field. So the charge is moving like this. So magnetic Lorentz force BQB sin theta. So what happens is that it is 90 degree. Sin 90 means it has the force of PQV. So it experiences the maximum force according to the Fleming's right hand rule. So point A and point B. So four side you can consider them the circle. All the forces are acting towards the center. இப்போ தான் நம்ம பார்த்தோம். அதே மாதிரி தான் இங்கே visual போட்டோம். Point B, point C and point D. So all the forces are moving towards the center of the circle. So the particle is moving in a circular motion due to the velocity of the perpendicular component. That particle is moving in a circular path. So particle on the magnetic field போடுறோம் என்ன ஆகுது circular pathல சுத்துது. ஏன் சுத்துது அப்படின்னா it has that velocity, that vertical component is parallel perpendicular to the magnetic field. So here VPA is parallel to the field. So the BQV becomes 0, means that is 0. So the no force in the PA. So PE only it is experiencing the force. So it is moving in a linear motion. It is not affected. So it is moving in a circular path because it's affected. So Lorentz force BQV sin theta becomes 0 for that P velocity in the direction of parallel. Parallel that means PA அப்படின்னு போட்டுருக்காங்க, perpendicular to PE போட்டுருக்காங்க. So PE perpendicular, it has experience of force. See that the two components. That's why the particles are moving in the helical motion. So ஒன்று ஸ்ட்ரெயிட்டாக போகும், ஒன்று சுற்றணும். அப்போ ரெண்டு சேர்ந்த மாதிரி பண்ணால் எப்படி போகும்? It is moving in the shape of helical spiral, like that. You can say that the helical motion of charged particles in the magnetic field. So next thing is so now you can see that north and south pole, again the same thing only. Again I am showing that another one presentation. So when the charge is moving inside the charge, that is magnetic induction is there. So VB is the velocity, B is the magnetic induction. And B into QV, BQV. So it experiences a force perpendicular to the velocity and magnetic induction. That's why the particles are moving in a circular path. So it is moving like this. So force in a upward direction. So here you are applying the magnetic field and electric field. First electric and the magnetic field, that is called the velocity selector. So velocity selector equal to V equal to E by B. Already you know that. ஏற்கனவே நம்ம இதை வந்து நம்ம 7th லெசன்லேயும் பார்த்துருக்கோம், 8th லெசன்லேயும் பார்த்துருக்கோம். So electric field and the magnetic field, they are cancel each other. So here that is moving in a circular path. And the 8th lesson நான் சொல்லியிருந்தேன் magnetic Lorentz force, that's why the particles are moving in a circular path அப்படின்னு சொல்லியிருந்தேன். So அதனுடைய இதுதான் இது. So how the particles are moving in a circular path, what is magnetic Lorentz force அப்படிங்கிறது இதுதான். So when the two pieces are perpendicular to each other, it will move like this. So in this we can change the velocity of the charges. So that's why this is called velocity selector.